Hello kids, today we are going to see some terms and not ray diagrams. Basically we are going to see some terms and rules for drawing ray diagrams for mirrors. Okay, for mirrors. So let's start. Okay, we have two types of mirrors in our syllabus, concave and convex. Okay, so what is concave mirror? So if suppose there's a sphere and its inner side, okay, its inner side is made shiny and outer side is coated. Outer side is coated. This is coated side with coating, and this is polished side. Okay, so what happens is if you cut this from here, you will get a mirror which is curved inward, right? So such type of mirror is called as concave mirror. What happens if we do the process in the opposite way? Suppose the outer side is polished and the inner side is having a coating of a substance with which we can make a mirror, maybe lead. Okay, we can coat this with lead, okay, or any shiny thing, right? Okay, we can have mercury, we can have silver coating, right? Okay, then you can paint this to protect this layer. So what happens if the outer surface is polished? Okay, suppose we cut this, so what we get is a mirror with outer side as a reflecting side, right? So this is called as convex mirror and this is concave mirror, right? So these are interesting mirrors to play with, but we'll stick to our topic, the terms and rules. Okay, so simple. With this sphere, okay, there would have been a center to that sphere, right? And we call this center as center of curvature. So C is center of curvature. If there is center of curvature and it's a sphere, then this here, the distance between center of curvature and this curve should be radius, right? So this R is radius of curvature. Okay, if I draw this entirely in a new way, so this would look like this. Okay, the center of the sphere is called as pole, right? And this we know, center of curvature, right? And this distance we know as radius of curvature, right? Okay, now we see the new terms. If suppose we draw a line which connects the center of curvature and pole, so that line is called as principal axis, right? Principal axis. Now assume that there are light rays coming parallel to principal axis. They'll reflect, okay, and they meet at a single point, and this point here we call as principal focus. Okay, and the distance between focus and pole, is called as focal length. So focal length is half of radius of curvature, right? And this will be the same case for concave mirror as well, right? Okay, concave mirror however is a diverging mirror. So if I draw concave mirror, convex mirror, so it's a diverging mirror. This will be principal axis. If there is light ray coming parallel towards the convex mirror, after getting reflected, they go like this, diverging, right? So if someone is seeing from here, he will get diverging rays and he might see the image at this particular point. Okay, and this will be a virtual image. We are not talking about virtual and real image in detail here, that is not the topic right now. Okay, so this is diverging. So this is what? This is focus, right? The focus of convex mirror is on the right side, so focal length is taken as positive. Focus of concave mirror is to the left side, so focal length is taken as negative. Okay, so remember this, converging and diverging mirrors, an important topic. Let's begin with the rules for drawing ray diagrams for mirrors. So suppose I am taking a concave mirror, so this will be principal axis, this is pole, focus and center of curvature. Okay, remember whatever distance you are taking from pole and center of curvature, the half of it will be the focal length. So suppose this is 6, so it's 3 and 3, it's 4, then it's 2 and 2. So rule number 1, if there are lines or light rays parallel to principal axis, after getting reflected, they'll come from the focus. Rule number 2 is the reverse of the same, center of curvature, focus. If there is light ray which is passing through the focus, after getting reflected, the reflected ray will be parallel to principal axis. And rule number 3, and this is an interesting one, pole, focus, center of curvature. If there is light ray which is passing through center of curvature, after getting reflected, it will trace back the same path. Isn't it interesting? So while drawing ray diagrams, we'll make sure that we follow 2 rules out of these 3. We'll use 2 rules out of these 3. Okay, so we'll see you in the next lecture. We'll draw some diagrams, right, at that time. Do your best, keep practicing. Bye bye.